Hello, good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
Am I audible?
Yes,
Yes, ma'am.
ma'am.
Hello,
Ma'am, can you tell what we mean by
am I
simultaneous?
audible?
Uh,
Yeah, ma'am, you are
yes.
audible.
Yes, ma'am, you are audible.
Okay, so today is the open session for week 7,
Ma'am,
and
I have a doubt in
we
week
will learn
5.
about the basics of probability.
Ma'am, I have a doubt in week 5 EMQ graded assignment.
My screen is visible now.
Yes, ma'am.
Say yes or no something.
Ma'am, I guess we are not audible to you.
Ma'am,
Okay, so I'm going to start now. Yeah, so the main topic of week 7 is probability.
Hello. Hello, ma'am, I am
So
audible.
most of the time you have listened to the people saying that there is a 30% chance that it will rain tomorrow, or there's a 50% chance that India will win the next match, or you have given a question which is a multiple choice question. You have 4 options, and you guess a random option. You say that option A is correct, something like this. Okay, so let me write it also.
Hello, ma'am, can you hear me now?
So we make statements like this.
Hello, ma'am? Hello? Hello?
I think we are not audible to ma'am.
Oh,
Yeah.
Or we make statements like that party ABC will win the next election.
I think ma'am headphone is disconnected and only mic is connected. Or maybe she is using
I
some.
think the headphone jack from the computer has been come
No,
up.
no, no. I think see
So in
there are
all these
options to
statements,
select audio
we
and
say,
video,
you can
audio and
see
mic
Oh,
that there is
he
a
devices.
he
element of
for she
uncertainty,
forgot to give the access of
right? So in
external
all
audio
these
video.
things, we are just making a random guess. We are predicting that it will rain tomorrow or this party will win the next election, but we are not 100% sure, right?
I think we
So there
should
is an
leave
element of
this meeting so
uncertainty.
that she know.
So here the probability comes into the light. So what probability does? Probability basically
please
tells
someone
us
type and
about
tell her.
the chance of something happening, okay? Or it is giving you the likelihood of something happening, right? Yes or no? Am I audible, right? At least reply yes or no some things.
Can you hear me, Prerna?
Sridhar, hello?
Ah,
Okay, I'm not
Sridhar,
able to listen any of you.
Sridhar, I think ma'am's output audio jack is not connected with his device. That's why she is unable to hear
please
us.
I'm
type.
audible, but
Please type.
you people were speaking something or not because I cannot hear any one of you.
Yes, we are speaking, but
Okay, let me do something because I cannot listen.
I just texted her. I think,
now you can listen.
I can hear you. That's only thing. Like, I can hear you. I can hear others, but I don't know why she's
she is unable to hear us. Some technical glitches happen, I think.
No, I think either because of some speaker to jack, jack to speaker, some issues with the output issues, or Bluetooth to the synchronization, something if they're using wireless headphones and the issue. No, I can hear you, but you can hear me.
Mhm. So, Sridhar, hello.
Mhm. Yeah, tell me.
Hello.
Yeah, can you hear me? Can you hear us now? Hello.
Please wait for a minute. I'm doing something.
So this is week 7, right?
Yeah.
Hello.
Yeah.
Yes, ma'am.
Hello, ma'am. Can you hear now?
Ma'am, can you hear us?
Can you hear us?
Still,
Can you listen to me now clearly?
Yeah, we can hear
Yes,
you.
ma'am.
Okay. I don't know why, but I can listen to you by my laptop speaker, but my earphones is not working.
Ma'am, it's not like maybe your earphone is not there in options, or you're not like getting sound after selecting the option also.
No, if it's a Bluetooth earphone, the battery may be down.
No,
Uh,
battery is full.
Oh,
Uh,
wow. Okay, you're here us now.
no, but I'm not using the earphone now.
Okay.
i- isn't it
Yeah.
available
Okay, I
in
thought.
option? You can select the specific option, like I showed the in image. There are separate options for
Yeah,
selection
I'm
of
showing.
microphone.
No, Himanshu, now she can hear us.
Mm-hmm. She can hear us, but she was saying like not able to connect to
Maybe
this.
you can try with a regular earphone if you're using Bluetooth.
Show your ma'am, please zoom screen. Then, uh, uh, okay, it's not visible. It's not coming.
Ma'am, share the entire screen. Then it will come.
So here I have selected these two options, but I
No, no,
cannot.
ma'am, not visible here. It is showing your PDF page only. You should share the entire screen first, I think.
Okay, ma'am, now can you hear us clearly now?
Yeah, okay, I'll use my laptop's microphone and then.
Okay, no
Okay,
problem.
ma'am. Then proceed. We can fix it later.
Ma'am, I have a small doubt in week 5 EMQ graded assignment.
Okay, week 5 is already done, you know.
Yes, but I have a small doubt in EMQ assignment.
You mean that simultaneous, right?
Yes,
Yes, ma'am. What the same things? What is simultaneous? What do you mean by simultaneous and one by one selection?
I have asked this in TA session, but he said,
Simultaneous is parallel. One by one is one after the other.
I think ma'am should tell us.
Yes, simultaneous means all at the same time, not one by one.
Means
I know the
it's a
meaning,
continuous
ma'am, but
process.
if you can
No.
open that portal so I can more clearly tell you what is
Okay,
the doubt.
let's first discuss week 7. Okay, then we will see that. Okay.
Yes.
Okay, ma'am. But I have a small doubt, not a big doubt.
Okay, let's first complete week 7 content, then we can move on to that. Okay.
Yeah, fine, ma'am.
Yeah, so I was talking about the probability. Okay. So these are the statement or few examples that you can see. So here you can see that an element of uncertainty is there. Okay. In all these things, we are not 100% sure. Okay. So here the probability comes into the light. Probability basically tells us about the chance or likelihood of something happening. Okay. So we can write it like this, that the determination of the likelihood or chance that an event will occur, right? Okay. So is this clear?
Yes, ma'am.
Okay. So now the next thing is random experiment. So what is an experiment? So experiment is nothing but it is a process that gives you some result, right? But there is a difference between a random experiment and a simple experiment. Okay. So suppose you are doing an experiment, you have a glass of water and you are mixing sugar, one spoon of sugar in it. Okay. That is also a experiment. Okay. But you know that it will give you in both the cases, like you have 2 glass of water and you're mixing one spoon of sugar. So both result of both will be same, right? Okay. Or you can say that if you are mixing, you are taking, so that will always give you water, right? Okay. So here you can see that already we know what will be our outcome. Okay. So outcome is already known. But in random experiment, we know the possible outcomes, but what exact outcome will occur, that we don't know, right? Okay. We know the set of all possible outcomes. Okay. But what exact outcome will occur, is not known, right? So you can take some example. So for example, you are tossing a coin, right? So whenever you are tossing a coin, you know that either it will be a head or it will be a tail, right? But we don't know what exact will occur. Okay, we know the possible outcomes, but what exact will occur, that is not known to us. Okay, similarly, if you are throwing a die, okay, in that case also we know that numbers from 1 to 6 will appear. Okay, but what exact number will appear, that is not known, right? Similarly, for example, you have a question, a multiple choice question, which have 4 options, A, B, C, and D. Okay, so you know that out of these 4 options, one option will be correct, but what exact will be correct is not known to us, right? So these kind of experiment are called random experiment, where we know the possible set of outcomes, but what exactly will occur is not known to us. Is this clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Okay. Or you can take another example also. Suppose you have 5 people, okay, and they are doing a race, okay, and you have to tell that you have to tell the first, second, third, and first, second, and third rank. Okay. So we know that out of these 5 people only, they will be coming first, second, or third. No people out of these 5 people will be standing for 1, 2, and third position. Okay, so the outcomes are known, but who will be getting the first, second, third rank exactly, that is not known to us, right?
Yes, ma'am.
Okay, so now the next is sample space. So do you know what is sample space?
Set of all possible outcomes.
Yes. Okay, so set of all possible outcomes is the sample space. Okay, so in the above example, you can see that if you are tossing one coin, then what will be your sample space? Your sample space will be head and tail. Okay.
Head and tail.
Similarly, if you are tossing 2 coins, okay, if you are tossing 2 coins, then what will be the sample space? Your sample space will be head, 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 tail, tail, head, and tail, tail, right? So that will be your collection of all the possible outcomes. Okay. Here also you can see that if you're throwing one die, then 1, 2, 3, 4, 5, and 6, that will be your sample space. Okay. And in this example, when you have a multiple choice question, okay, so all these 4 options will be your sample space. Okay. And here in this example, you can see that
Ma'am, but
yes.
all these things can't be happen in a pair. Once a time, once is will become either head or either tail. Uh, so you are taking 4 possibilities, but it is 2 possibilities, na?
Yeah, sample space is the set of all the possible outcomes, right? So all the possibilities we will be taking in the sample space. Okay. So either the head will appear or tail will appear. Okay. So all the possibilities will be there in the sample space. Okay.
Yeah,
Right.
yeah.
Okay.
Got it.
So here also 5 people were there. Okay. So all the 5 people, person 1, person 2, up to person 5. Okay. So all the 5 person will be making your sample space here. Okay. Okay. Now the next is event. Okay. So event is nothing but the subset of the sample space or a collection of some outcomes. Okay. So it is the collection of outcomes. Okay. Or subset of sample space. Right. Okay. So if you are, suppose you are tossing 2 coins. Okay. Okay. And you're taking the event as even number appears. Okay. So what will be the E? What outcomes will be there in this? Sorry. Showing two die.
Throwing one die.
Sorry. Yeah, sorry. Throwing one or two, you can take any.
But into we need to check whether both numbers are even.
Yeah, then we will
or
check both, or yeah, accordingly we will take the event. Okay.
yes.
So if you are throwing one die, that even number appears, then it will be 2, 4, and
2,
6,
4,
right?
6. Yes, ma'am.
Okay. So this is, you can say, so the sample space in this case will be 1, 2, 3, 4, 5, and 6. Okay. And you can see here that E is the subset of this sample space S, right?
Yes, ma'am.
Okay. And it is the collection of some outcomes. Okay. Sample space is the collection of all the possible outcomes, but event is the collection of few outcomes. Okay.
Ma'am,
Yes.
when we put restriction on our sample space, it becomes event.
You can say that, but like what type of restrictions you are saying?
Some conditions on
Yeah,
samples.
you can say that, because
Okay,
in
ma'am.
event, it's not like it will be containing few of the outcomes, not all. If it is containing all the outcomes, then it will become your sample space. Okay.
Okay, ma'am.
So event is the part of sample space or subset of the sample space. Okay.
Here in the case of
Okay, you
sample,
can take any
both in the
event.
case of sample and sorry, can you hear me?
Yes.
In the here in both in sample and the event, you are talking about an event which is an event. So 0 is should also be there, am I right?
I am talking about throwing a die.
Oh, okay.
Okay. Yeah.
Yeah.
So 0 will not be there.
Oh, good. Thank you.
Okay. So event can be anything, like it depends on you how you are defining your event. Okay.
Because when you specifically said even number, so I thought it should be there.
Yeah. So in this case, you can see on die you have numbers from 1 to 6. Out of these, what are the even numbers that can
Yeah, yeah.
appear? It will
I
be
can
2, 4, 6. Okay.
yeah, I understand. Thank you.
Similarly, you can take for odd number also, or multiple of 2 or multiple of 4. Okay.
Yeah.
So there can be many events. Okay.
Yeah.
Let's take another example. Like you are tossing 2 coins. Okay. You are tossing 2 coins. Okay. And you are defining your event like at least one tail appears. At least one tail appears. Okay. So what will be your sample space? Your sample space will be head, 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 tail, head, and tail, tail. Okay. And what will be your event here?
HT,
At least one tail. Yeah. So it will be tail, head, or head, tail, or tail, tail, right?
Yes, ma'am.
Okay. So this is your event. So you here also you can see that it is a subset of S. Okay. It is containing few of the outcomes, right? Okay. So in
Yes,
this
ma'am.
way, we define our event. Okay. Now the next is, so in event, you can take union of events or intersection of events. Okay. Suppose you have two events, E and F also I am defining. So F, you can take any event. So here you can see like at least one head appears. At least one head appears. Okay. So what will be F? So it will be head tail, or tail head, or head head, right? So now if you have to take the union of E and F, so what will be? So it will be the collection of all the outcomes in E and F. Okay. So it will be tail head, head tail. Okay. tail, tail, and head, head. Okay. And if you have to take the intersection, then intersection contains those elements which are both in E and F. Okay. So both elements which are both in E and F, it is tail, tail, and head, head, right? So it will be tail, head, and head, tail. Okay, so that will be your intersection for two events. Okay, now the next is null event. Okay, so what is null event? Null event is basically an event which does do not have any outcome. Okay, and we represent it by phi. Okay, null event. So suppose you have a you are tossing you are throwing a die. Okay, okay, and your event E is like even number appears. Okay, and your F is odd number appears. Okay, so E will be 2, 4, and 6. Okay, and F will be 1, 3, and 5, right? Now, if you take intersection of E and F, so what will be E and F? E intersection F.
Null.
Phi
Null, phi,
empty
okay.
set.
So we will represent it by phi because there is no element which is common in both. Okay, so it will be A intersection F, it will be a null event, right? Okay, now the next is disjoint events. Okay, so what is disjoint events? So here you can see that E and F, E intersection F was phi, okay? So you can see there is nothing common in E and F, okay? So you can see that E and F here will be disjoint events. Okay, so the events which have nothing in common, that are called disjoint events. Is this clear?
Yes, ma'am.
Okay. And this is also called mutually exclusive events. Okay, so if one event appears, then other cannot appear, right? So if even number appears, then odd number cannot appear, right? Okay, so E and F are mutually exclusive events also. These are same. Next is complement of an event.
Complement is nothing but the entire set minus the individual set. No, ma'am?
Yes, suppose you have an event E, okay? So see, this is your sample space, okay? And this is your event E, okay? So here you can, so this part, okay? So the all the outcomes which are not in E but are in the sample space, that will be your E complement, okay?
Universal minus E.
Okay, so complement, we write it like this, E complement. Okay, so all the outcomes which are in the sample space but not in the event E, that will be in your E complement. Okay. So when you subtract your event E from the sample space, that will give you complement of that event. Okay. And let me represent this intersection and union part also by the Venn diagram. Okay. So next is Venn diagram. Okay. Okay. So Venn diagram is nothing but the graphical representation. Okay. So it is the graphical representation that is useful for illustrating the logical relationships relations among the events. Okay. So how we represent an event or sample space through a Venn diagram. So it is basically okay. So in rectangular or square shape, we represent our sample space. Okay. And we represent the events by a circle. Okay. Okay. So suppose
Ma'am,
this is your event E
I,
and this is
I think you have missed the De Morgan law, no?
okay, I will tell you that also. Okay. So this is your two events E and F. Okay. This is what does this part represents?
Intersection.
Intersection.
Yeah. So it is the E intersection of F. Okay. And if you have to take union, then so E union F will be this entire region. Right? Okay. So this green part will be your E union F. Is this clear?
Yes,
Okay.
ma'am.
And if you have to represent subset, okay, suppose the next is subset. Okay. So if all the outcomes in E are also in F, okay, then we say that E is contained in F, right? Okay. Or we can say that E is subset of F. Right? And how we represent it in the diagram. So this is your sample space, suppose. Okay. And this is F. Okay. So this will be your E. Okay. So here E is the subset of F. Right? So here you can see in the diagram that all the outcomes which are in E, that will be in F also, right?
Ma'am, it's proper subset.
Uh, like proper subset is this and subset is this, right?
Yes, ma'am.
If I'm not wrong. Okay. So this will be your proper subset. But if
Yes, ma'am,
E
this is proper.
will be your subset, then E and F will be equal. Okay.
Okay, ma'am.
Okay.
Sorry, could you repeat that? The difference between proper
See
subset and
what
subset?
happens, like suppose this is your E, it contains few elements, okay? And this is another event F, which contains few events, okay? So in this case, what when it is a proper subset, when E is a proper subset, then there will be few outcomes that will not be in E but will be in F, okay? It will be your subset. Like here you can see that circle of E is smaller than F, okay?
Yeah.
At least one element will always be there, which will be in F, but not in E. But when we use this sign, like it is equal also, so in that case, it can also be possible that all the elements of F is in the set E. Okay, then in that case, the set E and F will become equal.
Oh.
Okay, yeah, this is the difference.
And in the above case, when we are representing about the complement, how can I write it in terms of the formula, like the way you write A intersection B or so on?
Sorry.
How can I mean, in the above previous example, when you described about the complement, before that,
So you are
Yes,
talking about how we will take intersection union if relation is like this.
no, I'm talking how do you represent, because you said E is complement. I mean, you put a C over the E, saying that
He's
E
asking
complement.
for the Venn diagram of complement.
So E complement will be all the other outcomes which are not in E.
Yeah, what I'm asking, how can I write it in terms of the formula, still mathematical expression, the complement.
Sorry, I'm not able to understand what you're asking.
He's asking for
Mathematical
Venn diagram of
notation for complement, right?
Mathematically, complement will be our E complement only.
Oh,
Yes.
he's asking that
asking
A
for Venn
complement is
diagram.
A to the power small c, which is the notation of
Maybe I will
complement.
come back. Maybe you proceed. Maybe I will come back and ask you in a different way. Maybe give me some time so that I will ask my question, put my question in a different way. Thank you.
Okay. So E complement will be your E like this only. Okay. If E and F are equal, then you can say that E complement and F complement will be same. Okay. If E and F are equal, right?
Okay, fine.
Yeah. So the next is. So next we studied about the classical probability. Okay. Classical or theoretical. So in classical probability, we say like if you have a sample space S, okay, you are doing a random experiment and the sample space is S, okay, and there are n equally likely events or sorry, equally likely outcomes, okay. So suppose there are total n outcomes are there, okay, and you are considering an event E, okay, then what will be the probability of E? So it will be the favorable outcomes. Favorable outcomes. Okay. Suppose it is M in number. Okay. Divided by the total outcomes. Okay. And total outcomes here we are representing it by N. Okay. So the probability of E will be equal to M divided by N. Okay. And here we say that the outcomes are equally likely. Okay. All the outcomes are equally likely. So what does mean equally likely? Equally likely outcomes mean that all the outcomes have equal chance of being occurred. Okay. So suppose you are tossing a die, you are tossing a coin or you are throwing a die. So we know that the probability of occurring a head or a tail are same, right? If it is a fair coin. Okay. And same with the die also, all the numbers have equal chance of being occurred, right? So here we can say that all the outcomes are equally likely to occur. Okay. So in that case, we use classical probability. So the probability of any event which we are defining, that will be the favorable outcomes, number of favorable outcomes divided by the total number of outcomes. Okay. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. And the next is the relative frequency. Okay. Or we can say the empirical probability. Okay. So in this, what we do, we perform an experiment a large number of times. Okay. And then we try to find the probability of an event happening. Okay. So how we define it? So this is the probability of E. In that case will be M divided by N, but N should be very large. Okay. So it will be so you can write like number of times an event occur divided by the total number of times you are performing an experiment. Okay. And limit N tending to infinity. Okay. So theoretically, we can write it like this. Okay. So the probability of an event in an experiment, okay, is the proportion, or we can say fraction also, proportion of fraction of times the event occurs in a very long series of independent repetitions of experiment. Okay. So here what NE is representing? So NE nothing but the number of times that event occurs. Okay. Suppose we are performing an experiment 50 times. Okay. So then N will be your 50 and you are defining an event E that appears 20 times. Okay. Then 20 divided by 50, that will be your probability for that particular event. Okay. Is this clear?
I'm just little bit scroll up. Just okay. Now you can proceed further.
Ma'am, you said this
Yes.
relative frequency. So we have to perform an event or a experiment a very large number of time
Yeah. So it is
to
basically,
approximate the
hmm,
probability, right? Like we
yes.
don't know and we try to get it somehow. Like
Yes.
we have a coin, we made it by ourselves, so we don't know whether it is equally
Yes.
likely or
So we
not.
can
And
perform the event a large number of times, and then we see that how many number of times that particular event is occurring. Okay.
hmm.
So
And
basically, it is
then
the relative
yeah.
frequency, like frequency of that event. Okay. Like if
Hmm.
you are doing an experiment 100, suppose 100 times, and 60 times an event appears. Okay, so 60 is, you can say, like it's frequency of that event. Okay, so the 60 divided by 100 will be the probability.
And then, ma'am, those event which we are testing should be fundamental events also. Like if we have a dice that we made ourselves, then event should be like one, two, like individual numbers, not combined maybe, because then we have a like we try to get the individual number and check the probability and then sum up somehow.
Sorry, I cannot understand what you are saying.
Like if the event we are choosing is already having some kind of processing, like let's say we I say even numbers on our die, then it
Yeah.
has three outcomes, and my die is not fair. I am checking for the probabilities of individual number, then I should take experiment as individual numbers. Is this correct?
So you are saying that your die is not fair,
Hmm.
and you are taking an event of occurring of even number.
Hmm. Then should I take this experiment or I take first experiment for individual numbers
No,
and
event you can
map the
event you can
probability?
take any event. It's not like you are restricted to take some events only. Okay.
Okay. Okay, so we are not restricted
That's
to
why
the
it is
events.
empirical.
Hmm.
Okay,
Hmm.
so you
Hmm.
are performing, maybe you are now you are doing a experiment 100 times, and it is giving you that number of heads as 50, and you are doing the same experiment 100 times like tomorrow. Okay,
Hmm.
then it will be suppose it will be giving you 70 times. Okay, then it could change.
Okay.
Okay, and the next is the subjective probability. Okay, so next is subjective. So subjective, as the name suggests, that it is subjective, so it will differ from person to person. Suppose you're asking, you have five people, and from all the five people you're asking that what are the chances or the probability of raining tomorrow. Okay, so someone is saying, one is saying that there is 50% chance, another person is saying that there is 60% chance. Okay, or someone is saying that 45% chance. Okay, so in that case you can see that it is subjective, it is differing from person to person. Okay, so this kind of probability we say that subjective probability, in which different person having different perspective. Okay, so it is nothing but like a best guess that a person can give. Okay, so it is not mathematical, it is rather subjective. Okay, now the next is, there are some axioms of probability. Okay, so there are few axioms. So probability, we know that it lies between 0 and 1, right? So probability of any event, okay, will be less greater than or equal to 0 and less than or equal to 1, right? This should be clear to everyone.
Yeah.
Okay. And the next is the probability of the sample space is 1. Okay.
Yes, ma'am.
Okay. So what does it mean? That the outcome of the experiment will be an element of the sample space with probability 1.
right? Is this clear? Okay, so whenever you are doing an experiment and you are getting some outcome, so that outcome will definitely belong to the sample space. This probability is equal to 1. This is sure, right? And the third number is that for a sequence of mutually exclusive or we can say disjoint also, disjoint events, even, even, okay, and so on. So the probability of their union, okay, that will be equal to the summation of their individual probabilities, okay. So here you can see that the events are mutually exclusive. That's why the intersection part will be 0. Okay. So the probability of their union will be equal to the summation of individual probabilities. Right? Is this clear? For two events, we can write it like this, that probability of E1 union E2, that will be equal to the probability of E1 plus probability of E2. Okay. We can generalize it for two events like this. Right?
Disjoint events, right?
Yeah, for disjoint events only.
Oh,
Okay.
okay, okay.
Okay, here it is written that mutually exclusive events. Okay. Okay. And there are a few other points also. That probability of E complement, that will be equal to 1 minus probability of E. Right? Okay. So how we can prove it? So we know that E and E complement are disjoint. Right?
Yes, ma'am.
Okay, that will always be disjoint events. Okay. And we also know that E union E complement, that will be equal to S. Okay. So suppose this is your sample space. Okay. And this is E. Okay. So if you take union of E and E complement, that will be equal to sample space.
Actually, I was asking this one previously when you expressed about complement.
Sorry.
I was asking about this only. How do you represent when you asked you how do you represent the complement? I was actually asking in this
So
term.
E complement, this is E. This will be your E complement. Okay.
So now the
Remaining
way you
reason.
have projected the property, yeah, the same thing I was asking that time.
Okay.
Thank
Okay. Okay. This reason.
What he asked?
How we will represent the E complement in the Venn diagram, right?
Oh, Venn diagram.
Venn diagram as well as in the way the probability thing you have expressed returns this thing on the left hand side. The P of E complement is equal to 1 minus P of E.
Yes.
So
Okay. So this reason will be your E complement. Okay. And if you have to find the probability of E complement, that will be 1 minus probability of E. Okay. So if you take probability on the both sides, probability of E union E complement, it will be S. Okay. So here you know that E and E complement are disjoint. Okay. So we can write it like this, probability of E plus probability of E complement, right? And from the axioms, we know that probability of the entire sample space is 1. Okay. So this we can write it equal to 1. Okay. So from here you can write that the probability of E complement, it will be equal to 1 minus probability of E. Right? Okay. And probability of a null event, so that will be equal to 0. Okay. So null event means it is not containing any outcome. Okay. But if you are doing an experiment, then you will get some outcome. Okay. So probability of null event will always be 0. Okay. And if you are taking the complement of sample space, that will always also be phi. Okay. Is this clear?
Yes, yes. Sample.
Yes, ma'am.
Why is it pi? The complement of complement space?
Okay. You have all the possible outcomes here in this region,
Okay.
in this entire rectangular region. Okay.
Okay.
So there is nothing possible, no possibility out of these. Okay. So it will be a null event.
Okay.
Okay. So you can also write it like this. Probability of S complement will be 1 minus probability of S. Okay. And probability of S is always 1. Okay. So probability of S complement will be 0. Okay. So S complement is a null event. Okay. And probability of null event is 0. Okay. Now it is proved.
Yes.
Now there is a addition rule of probability. Okay. So suppose if you have two events, okay, two events, E1 and E2. Okay. So the probability of their union, okay. So in the earlier we have seen that uh, when E1 and E2 are disjoint, okay, when the events were disjoint, then the union probability was equal to the summation of their individual probability. But what if the events are not disjoint? Okay. So if the events are not disjoint, then the probability will be equal to probability of E1 plus probability of E2 minus the intersection of. Okay. So here E1 and E2 are not disjoint. Okay. And you can see from here also. Okay. So this is the general formula. If in case even and E2 are disjoint. Okay. So in that case, that will be equal to 0, right? Intersection part will be 0. If even in E2 are disjoint. Okay. Then again, it will become the probability of E1 union E2. It will be equal to probability of E1 plus probability of E2, right? That we have seen earlier. Okay, but if they are not disjoint, then we will use this formula.
So in the previous, I mean, in the discussion, you mentioned the disjoint case as a mutually exclusive event, am I right? So here
Yes.
it will be an antony of that. It will be mutually inclusive one here.
Yeah, here they can be inclusive. Like they can have some elements in common. Okay.
So it's inclusive event.
Okay. So here intersection part will not be 0. There will be some element in the intersection also. Okay. So like in the Venn diagram, you can see if two events E and F, okay, if they are not disjoint, okay, then there will be some portion in common, okay. But if they are disjoint, okay, then we will represent like this. Okay, this is E, this is F. But here they are not disjoint. There are some points which are common in both. Okay. Is this clear now?
If this is
Yes,
not
yes.
disjoint, then we can take probability of E1 intersection E2 as 0.
If they are disjoint,
Hmm.
okay, if they are disjoint, which is this case, okay,
Hmm.
then there is nothing in common. Intersection will be 0,
Hmm, hmm, hmm,
right?
hmm.
But if they are not disjoint, okay, then we will take this part also, intersection part, okay, which is this.
Ma'am,
Yes.
ma'am, why is it called addition rule?
because of PE, the probability of E1 plus probability of
Like
E2.
addition, we are adding two probabilities, you can see here. Okay, so probability E1 union E2. Okay, so you can see that this is E1, this is F or E2 you can take. Okay, if it is E2, so you are adding these two probabilities. Okay, probability of E1 and E2, but you can see that this portion is added two times, right? So that's why
Yes,
we are
ma'am.
subtracting the intersection part. Okay, because it is added two times. Okay, so we subtract
Yes,
this
ma'am.
intersection part. Okay, and it is called addition to. Okay.
Yeah, my question may sound naive. I just want to clarify. In probability as such, we see addition and subtraction division. There is no multiplication in probability at all, is it? Or I'm not. I didn't follow properly.
There is multiplication rule also. Okay, that we
Okay.
will you will study in the next week, I think, in week 8,
Oh,
I think.
okay.
Okay. Yeah.
Thank you.
Okay, so we will solve one question. Okay, suppose we have a question that a customer, goes to a clothing shop or store. Okay, and the probability that he purchases a shirt. Okay, this probability is given as 0.3. Okay, and the probability that he purchases a pant. Okay, so that is given to us as 0.2. Okay, and the probability that he purchases both shirt and pant. Okay, so that is given to us as 0.1. Okay, now it is asked that what proportion of customers purchase neither a shirt nor a pant. Okay, so let us suppose that S is an event. Okay, that represents that he purchases a shirt. Okay, and B is a event that represents that he purchases a pant. Okay, now what is given to us, the probability that he purchases a shirt, it is given as 0.3. Okay, and probability that he purchases a pant, it is given to as 0.2. Okay, and he purchases both. So what does both, how we will represent this, that he purchases both S and P, means shirt and pant? How we can represent it? It will be S intersection P, right? So whenever two events like A and B, A intersection B means both occurs. Okay.
Yes, ma'am.
Okay. So here what it is saying, that he purchases both shirt and pant. Okay. So that we will represent it like probability of S intersection P. Okay. Is this clear?
Yes, ma'am.
Okay.
Well, how you get this 0.1? Okay, it is given in question.
Yeah, it's given in the question. Okay. This is
Okay.
your question.
Hmm.
Okay. And
Okay.
written the information that is given in the question. Okay. Now what you have to find, the proportion of customer. Okay, that customer purchases neither a pant nor a shirt. Okay, so customer purchases a shirt, it is S. Okay, not purchase, that means it will be as complement, right? Purchases a pant is represented by P. Not purchasing, it will be P complement. Okay, and here it is written that neither a pant nor a shirt. Okay, so it will be intersection. right? Okay, neither he's purchasing a shirt nor he's purchasing a pant. So, okay, so it will be S complement intersection P complement. Okay, so this proportion or probability we can say that we have to find. Okay, so that we can write it like this also. Probability of S union P whole complement. Is this clear? So this is basically the De Morgan's law. So suppose if you have, okay, so you have two events A and B, okay, A and B. So A intersection B whole complement, that you can write it like this: A complement union B complement, okay, and A union B complement, you can write it like this: A complement intersection B complement. Is this clear or any doubt?
Excuse me, ma'am. Can you please explain this again?
Okay, so here it is A intersection B complement. Okay, so what does it mean in theoretical terms? So A intersection B means both occurs. Okay, but here what we are taking complement. Okay, which means both will not occur.
Yes, right, ma'am.
Okay, so it will be A complement and union of B complement. Okay, so whenever here it is the intersection, then it will be a union. Okay, and when here union, then here it will be intersection. Okay, and complement goes like this: whole complement, then it will be individual complement. Okay,
Okay, ma'am.
okay, so in next also you can see that A union B, so you are taking the complement of E. So A union B means either A occurs or B occurs, but we are taking its complement. Okay, so it will be A complement, neither A occurs and nor B occurs, right?
Yes, ma'am.
Okay, so now here you have to find probability of S union P whole complement. Okay, so this we can write like this: 1 minus probability of S union P, right?
Yes.
Okay, and S union P, so we can write it like this: that probability of S plus probability of P minus probability of S intersection P, right? And these probabilities are given to us. So it is 0.3, it is 0.2 minus 0.1. Okay, so it will be equal to 0.6. Is this clear?
Ma'am,
Yes.
ma'am, first we are calculating either shirt or a pant, and then we are doing its complement, right?
Yes.
Okay, ma'am.
Okay. So you can use these formulas. Okay.
Excuse me, ma'am. What can be the question if we want to find a probability of S union probability of P?
Sorry, probability of S.
Union probability of P. If we want to find this particular value, then what can be the question for this?
Okay, so you are asking for this, right?
Yes, ma'am.
S union P.
Yes, ma'am. So if we
Okay.
want to find the value of this, then what can be the question?
Yeah, so it will be like either he purchases a shirt or he purchases a pant. Okay. Okay. So intersection gives you both, but if it is A union B, okay, then it means either A or B. Either A or B.
Okay,
So
got it. Thank you.
basically the simultaneous one and the independent events.
Sorry.
Basically, the first one is the simultaneous event and second one is the independent event.
Yeah, your voice is very low.
The first one is a simultaneous event, whereas the second one is an independent event.
See here in the intersection, both the events are occurring together. Okay.
Yeah. So it's simultaneous one.
Simultaneous. Yeah, you can say simultaneous also because both are occurring at the same time. Okay. But
Yeah.
here you can see A union B, like either A will occur or B will occur. Or we interpret it like this also, that at least one of two events. Okay,
Yes.
then it is A union B.
Yeah. So independent one. Thank you.
Okay. Yeah. And the next question. So a student has 40% chance of receiving an A grade in statistics. Okay. And 60% chance of receiving an A grade in mathematics. And 86% chance of receiving an A grade in either statistics or mathematics. Okay. Then we have to find one is does not receive an A in either statistics or mathematics. Okay. And receives an A in both statistics and mathematics. Okay. Okay. So let us suppose S is an event which represents that receiving an A. Receiving an A grade in statistics. Okay. And M represents receiving an A grade in mathematics. Okay. So probability of S, it is given as 40% chance. Okay. So it will be 0.4, right? And probability of M will be equal to 60% chance. Okay. So it will be 0.6. Okay. And it is given that either in S or in M. Okay. So it will be union, right? Which means probability of S union M, it is given to as 0.86. Is this clear?
Yes, ma'am.
Okay. So it is 6% chance of receiving an A grade in either in S or M. So it will be S union M. Okay. So now the first part, we have to find does not receive an A in either S or M. Okay. So either S or M, we can write it like this, that S union M. Okay. But it is opposite of it, like complement.
Complement.
Okay. Does not receive. So we can write complement of S union M, right?
Yes, ma'am.
Okay. So this we can write it like this, 1 minus probability of S union M. Okay.
Yes.
So which is 1 minus 0.86. Okay. So it will be 0.14, right? Is this clear?
Yes.
Okay. And in second, it is asked receive an A in both S and M, both statistics and mathematics. Okay. So both means we have to find the intersection part. So it will be probability of statistics intersection mathematics, right? Okay. And by the addition rule, we can write it like this, that the probability of S plus probability of mathematics minus probability of S union M. Okay. So this is the formula of addition rule. Okay. We have just interchanged the terms. Is this line clear?
Yes, ma'am.
Okay. So this probability is given as 0.4. Okay. And this is 0.6. Okay. And union, it was 0.86. Okay. So again, it will be equal to 0.14, right?
Ma'am,
Yes.
ma'am, that will be S union
S union.
M. Because when we study the addition below the probability, there is S union M.
So you are talking about this line.
Yes, ma'am. Oh, okay.
Yeah.
We interchange. Okay, okay.
Yeah. We interchange the term. Okay.
Yes, ma'am. Yes, ma'am.
Okay. That's the same. Yeah. Any doubt?
No, ma'am.
Yeah. So these things were in the week 7. Okay.
Ma'am,
Any doubt?
share your summarization notes with us because it will help us in quick revision.
Yeah. This notes.
Yes, ma'am.
Yeah. We will share that.
Because the week 7 content is too much vast. So we have to revise in a quick manner. So
Yeah.
that
We will
it will-
upload this PDF. Okay.
Or you can share in the chat box. Because
Don't worry. It will be uploaded on the portal. Okay.
uploading take 3 to 4 days. The deadline will be fast after that.
Okay. Okay. I'll share. Okay.
Ma'am, will you tell us how to do like extra activity, ma'am?
Extra activity, I'm not sure about that thing.
Yeah, I just want to inform you the graded assignment solutions are not loaded after week 3.
Exactly,
For
sir.
week 4 and 5.
Yeah, it's not yet
After.
uploaded.
Yeah, okay. It will be uploaded after some time.
It is not only happening in stats, also maths also. Stats and maths are very problematic in the graded assignment solution. Please, ma'am, do something from your end.
Okay, yeah, it will be uploaded in some time.
Ma'am, what should we do in like extra activity, ma'am? As it is deadline is coming, ma'am, coming soon. 13th, I think, deadline.
Ma'am, can you please open the portal? We will guide you to the extra activity and then you will explain from the instruction. आपको कैसे जाना है मैं ये बोल देता हूँ लेकिन आप थोड़ा सा इंस्ट्रक्शन को क्लियर कीजिए.
Actually, I'm not sure about the extra activity part. Okay, you can ask to Manoj sir or any TA. Okay, or I will tell you in the next session. Okay, I will ask about it, then I will tell you. Okay.
Manoj sir session was in the week 5, but extra activity given the recent week.
But the week, like deadline is coming soon, ma'am. I think 13th is the deadline.
No, the deadline is 13th.
Are 1-3, yeah.
Okay, what's your doubt in extra activity?
We
Extra
know how.
activity 2. वहाँ पे देखिए गूगल स्प्रेडशीट क्रिएट करना है एक. आप देख पा रहे हैं?
We know how to create a portal like a student portfolio, but we don't know what should we do in a spreadsheet, ma'am.
Yes, Roshni, it's like this. You just same in the same Google account. You go to Google Sites. open a page called statistics, and in the statistics you just create a, either you can create an independent Excel sheet or you can create a Google spreadsheet itself, and you actually download some data, data which has almost 1,000 rows, and either you can upload that entire data into that, or copy and paste it in the Excel in the Google spreadsheet. And once you do that, for each and every data, for example, if it's a, let's say it's a student and a mark and grades and so on. So for each and every data with the name of the student, the mark, the grades, and the date of birth and all the things, for each and every data that you say, we need to say what kind of a variable is that, whether it's categorical or whatever it is. You need to
Mm-hmm.
define each and everything. So
But
this is the whole, this
but
is the
Sridhar,
whole activity for the.
Sridhar,
Mhm.
we have to put for each and every 100 rows, 1,000 rows. It is
See,
quite
for yeah.
impossible, no?
No, that's what I'm saying. If you know one date of birth, the same date of birth is the same for everything. You don't have to do it for. So if you have date of birth column, if you have a name, if you have a address column, if you have a rank column and all the thing,
Mm-hmm.
in even though it has 1,000 rows, the idea is you should have a data of 1,000 rows, and
Oh, I have to
maybe a
fill just.
column of
I have to give just one column, one row for each and every column.
see, let's say that you are actually building a column, building a Excel sheet of 10 columns and 1,000 rows. Okay, this is the data that is required, and each column is independent column which has its own data. As I told you, name of the student, mark, grade,
Mm-hmm.
address, PAN number. I mean, whatever it is, the roll number, everything, and the thousand data of 1,000 students. So as the, you know, if the name of the student is a one it is a one variable, and the date of birth is another, and so on and so forth. So you have to give define what is each column, which column data belongs to which variable. Once you do that, then based on that, in the same case, like the second part is you will create a chart based on that, visualization part. Let's say that the rank of the student, let's say in thousand, all the 10,000 case, if you cluster them, then all they all will come under different clusters out of
No,
100.
no, Sridhar. Uh, each and every column contains a variable, individual variable, which is maybe categorical or numerical. I don't know. Hmm.
That is what you need to say. What is the
Huh?
what is the variable?
Now I am assuming because I didn't make it.
Yeah, yeah.
So
So
I am assuming that it could be a categorical or numerical, based on which I have to describe why it's categorical and why it's numerical and why it is continuous and
no,
why it is
see,
discrete.
Divya, don't take this. Just say let's say that school student data. Just assume a school student data. School students have 1,000 school student data. So you know what they will have. They will have a name. They will have a roll number. They will have a date of birth. They have a class they whichever class they belong to, and let's say they are subject. They are each of them are from, let's say from class to 6 to 10. It will be a common subject. So it will be all the English, maths, and physics, and whatever it is you say. It will be the case. And let's say that based on each subject they would have scored different marks in let's say the final exam, the end semester exam. That is one part. And the final grade, once you give that the final grade that you will be, the CGPA that you will be giving for each all put all together. So again, these are independent data. These are the things. So let's say if you have all these data, you know what is where the name belongs to which variable, you know where the date of birth belongs to which variable, and so is the case of grade and score and so on. So in after creating this 10 into 1,000 rows, 10 into 1,000 rows column, below or above, you can say, okay, the name is belongs to this variable, the rank belongs to this variable, and date of birth belongs to this variable. So these are the case you have to say there. That is what is expected there.
I have pasted the sample link for this. Ma'am, can you please open?
Do we need to draw any graphs or pie chart regarding this data?
Yeah, that's what they say. Visualization. It means that you will, based on the data, you will create different charts, whether pie chart or bar chart, whatever it is, and you will show how the data is there. This is what is the activity for the week.
Did you
All this
done?
thing, all this thing you'll be creating in a Google site.
And after giving the permission to IIT Madras, and then I have to create my website on the Google site, no? See that?
Yeah, your website should be in such a way. As
I can give it any name. that they are giving me HTTPS hashtag, and after that IIT Madras tagline, and after the slash last slash I have to give my
let's say
own
that
website name.
Your Google site itself, let's say you keep it as Jibya Marjandar itself, you keep your Google site. That link, whatever the website link, that is what you are going to share with them. And it should be public. It should not be a private. In the Google site, when you create, there are 3 different options.
Yes,
One is
yes,
that,
I
so,
published it.
yeah. So
I
once
have.
you publish that link, you have to submit to IIT Madras.
Yes, I published to it. I click on the publish, then I go to manage, and then the setting, then I select from there IIT Madras and give the access. I already done.
That's it. Over.
Just I have to just paste the link to the portal, but after pasting the link didn't working. Okay, brother.
After pasting, it's not working.
After
I
pasting the
didn't
link,
understand
link
that part.
isn't available for anyone, because I am myself didn't access the link after pasting.
No, do one thing. Once you said you publish it, am I right? You
Hmm.
copy that link and open a new window. Totally, if you have done in Mozilla, you open an internet browser, or even in Mozilla, if you open in incognito and paste the same link and see whether you can accessible within your system. If it's public, it should be accessible. So you don't have to test anything more. Just if you have created an incognito, go out of incognito, copy and paste the link in a new window, open a new window, copy and paste there. And if you can see your contents there, in
Yes,
everybody.
yes, I can. Yes, I can.
Then everybody will be able.
But I am thinking about the invigilator can.
Yeah,
Because
of course. If you see, if the process, whatever I told, based on the process, if you can see that, if the same link you have copy and pasted there, the investigators will, whoever is going to see that, they will also be able to see that.
Can we take any type of examples?
Yes, it depends on you. You can take any data for your economy.
Did you complete it?
But I didn't complete it. I am just opening the site and giving the link that I am accessing. I didn't complete it.
No. See, why you want to give a link before even completion?
Just checking. I am checking because I am because of packed up schedule. I
See,
didn't
okay,
get time.
till 13th you have this thing, so you can submit a number of times. That's not an issue. So,
But I didn't even open the Google portfolio. I am just creating the trying to create the Google spreadsheet at first.
Yeah. So
because I am facing the
website
problem creating the Google spreadsheet also.
Yeah.
Portfolio तो बहुत दूर की बात है.
Spreadsheet is not a big deal. You click spreadsheet is going to open. What is the big deal there?
That's why I am sharing
Google
the
tool
link.
itself in the Google website. When you go to the Google site and you click the tools there, you can see a Google spreadsheet there. You click on it, it will open.
Do we know that? Do we do that in spreadsheet or in Excel?
See, if you do it in Excel, then you import it to the Google website. Automatically, that will be converted into Google spreadsheet. But if you are comfortable with Excel only, then you can copy and paste it. I mean, let's say that you download an Excel sheet, Excel data from somewhere, that you import it to the Google site, automatically will take into that, and then based on that, you create all the visualization within Google and create charts or bar chart, pie chart, whatever.
Sridhar, the link which I have sent in the chat box, please open it and see. They are giving the information until the row 9. So I have to give the information until row 1000 or until some row or just one row.
No. See, this Google sheet is a data sheet or it's your web link. The link that you are the link that you have just now shared looks like docs.google.com. Am I right? This is a Google spreadsheet that you have shared.
Google spreadsheet, which is given from IIT Madras. I haven't created till now. I didn't do anything right now. Okay.
When did
मैंने
IIT
कुछ
Madras
नहीं
give
किया
a
है
Google
अभी भी.
spreadsheet?
मुझे तो समझ ही नहीं आ रहा है कैसे करना है. ठीक है.
No, but when did IIT Madras give you a Google Excel sheet? Because they don't
It's a
provide
sample,
any
sample.
data.
हाँ सही है sample sheet है sample sheet.
Oh, okay.
Sample.
So see, this is what. So the same thing in the same, you can actually follow the same thing. Now you can see the gender is categorical variables and so on. They have clearly. If the same data you try to download some data with 1,000 rows and do the same format you follow and do it. That's it. Either you introduce a column in between and say categorical and so on, or you can say the gender variable, the variable and the gender is actually gender is a category variable. If you put all the list on the top of the Excel sheet, that also is okay.
Oh, so I have to just explain for the columns, not for the rows.
No, basically, based on the column only, your category will come now. Why? How the row based? How will you do that? The row doesn't. The row is kind of all the rows will be under one column will be the same, right? Identical, right?
Do we need to give explanation like why it is a categorical and numerical?
Yeah, that is what they are asking. What is the data you need to explain?
Yes, they want to know the reason.
For 1,000, that many.
No, Roshni, like see, as I told you, let's say if the name of the student is there, and you say there are male, if you want to segregate as male student and female student, all male student is a categorical variable. So is the case of female student.
Yeah, okay.
Why you want to? You don't have to do it for 1,000 times, right?
Yeah. Thank you.
Like for gender, we write it as a categorical variable, and numbers means rank we write as a categorical variable, and marks as a numerical variable. All the marks come in that part.
Yeah. So why you want to do 1,000 times? Adi, I mean, we have been discussing. I don't know what Prerna is there. I'm sorry, Prerna. I didn't.
Hello, ma'am. Hello. Hello, Prerna, ma'am.
Yes.
Have you opened the link?
No, I have not. Your doubt is clear or not?
Yes,
A
ma'am.
little bit clear. First, I have to do just. I haven't do anything.
Sorry.
After doing something, I will.
Before I forget, this is regarding EMQ. We also mentioned the TA session. The EMQ, we are not having the solutions for the EMQ.
I have mentioned there.
That is also to be actually uploaded.
Okay, we will discuss that and solve that issue also. Okay.
Thank you, sir. Yeah.
Ma'am, one question. What like in this EMQ, there is option of simultaneous and one at a time. So when we should select simultaneous and when we should select one at a time, and can you open a few like open the page and solve few questions?
This simultaneously means that at the same time you have to do something. Okay.
Ma'am, can you show
You
with
have to
example?
select two balls simultaneously. Okay. So you are selecting two balls at the same time. Okay. And one by one, which means that you have selected one ball. Okay. Then again you have selected another ball. Okay.
So
That is at different point of time.
So does this have any effect on so this question from week 5? So is it having any effect on permutation combination?
Yeah, it will change.
So ma'am, can you open that and uh, just one, two questions where you can show which one should be selected?
I have to look for the questions.
Yeah, it is in week 5 graded EMQ.
Okay, see, I will solve all these doubts in the next session. Okay, regarding ENQ and like extra activity. Okay.
Okay.
If you don't mind, Prerna, just a minute. Hey, Himanshu, when you are asking about the simultaneous event,
Yeah,
just the example that she was discussing today, picking up a shirt and pant, that's a simultaneous event.
shirt, then pant,
Together.
simultaneous. Okay. Then what
That's a
is
simultaneous.
the example of one by one?
If I'm going to pick up shirt first, then I come later for to pick up pant, then this one after other.
Yeah, but is
Am
it
I right,
not
Prerna?
same whether the
No, let me confirm. I think Prerna, am I correct in this case?
Yeah, you have given the example like you have selected two things at the same time. Okay, at the same time means simultaneously.
yes?
Okay, one by one is different.
But if it is without replacement, then both the things will produce same
Like you have
permutations
10
or number of
things. Okay,
outcomes.
like you suppose you have 10 things. You have to select two things simultaneously. Okay,
Yes, ma'am.
so simultaneously you have selected two things. But if you have to select one by one, okay, then suppose you have again 10 things. Okay, first you have to select 10 things. Sorry, one thing. Okay, you have 10 options.
Then
Okay,
what is the effect of
but if you
combinations? Like
so
selection we are talking about. So is it will be like for a simultaneous? I also write 10C1 times 9C1. No, sorry, 10C2. And will that be like 10C1 times 9C1? Is this the
okay,
formula?
let me complete my line first. Like
Okay.
in the second example, you have 10 things. Okay, you have to select two things one by one, and you are not replacing. Okay, so first you have 10 options. Okay, you have taken one thing, one ball or something you can say. Now for the second thing, you are having only 9 options. If you have not put it back.
Okay. Yes, ma'am.
Okay, so it will change.
So the combination, total combination will be 10C1 times 9C1.
Yeah, so in the second case, for the number of ways will be like for 10 into 9.
Okay, so that's 90.
Like for one option, for first thing you have 10 options. For second thing you have 9 options. If you're
45.
not replacing it. Okay, but you are selecting two things at the same time. Okay, simultaneously, then it will be like 10C2.
10C to 90 and 45. Also. The outcomes will change.
Okay, I have doubt today from the today session itself. You are
Okay.
explaining one of the law, am I right?
Yes.
Could you actually describe it once again?
Probability axioms.
I forgot the name. No.
Okay.
You are talking. Yeah, in that case, you mentioned about what law is the name of the law? I forgot.
De Morgan's?
De Morgan's
Yeah, De
law.
Morgan's law. Yeah.
Okay, 1 second. Yeah, is this visible now?
Yeah, it's visible.
Okay. So this is your De Morgan's law. So what A intersection B? So A intersection B means both the event A and B are occurring. Okay. And here we are taking its complement. Okay. So it will be that both the events not occurring. Sorry. One minute. We can make the Venn diagram also. One minute. Okay, so here you can see that A intersection B, which means this part,
Yeah.
right?
Yeah.
And it complement will be the all the remaining part, right?
Yeah, the rest of it. Yeah.
Okay, and from this part, like A complement union B complement. Okay, so here you can see that A complement will be okay. So A complement will be this. Okay, just okay,
Including B.
including B, not this. By mistake, it is also color.
Yeah, yeah. Fine.
Okay.
Yeah, except B.
Okay, and union B complement. Okay, so B complement will be like you have to leave this B part and the
The rest of it.
other part. Okay, okay. So from both the pictures, you can see that complement of both are the complement of each other. Okay.
Yeah.
Okay, so it is A intersection B. Okay, so complement of this will be this.
Yep.
Apart from this part. Okay, and from this is also the same figure. Okay, A complement.
Union B complement.
Okay, union B complement, right?
Yeah.
Okay, this part only will be remaining. All the other part will be covered.
Okay.
Is this clear now? And
Yeah, yeah.
similarly, you can do for the second part also, like A union B whole complement. It will be A complement intersection B complement. Okay. So we can make Venn diagram for this also. Okay. So A union B. So A union B will be this. Its complement will be this. Uh, right?
Yes.
Okay. And here A complement intersection B complement. Okay. So here also if you draw, okay. So A complement will be this. Right? And
Yeah.
B complement will be this part. Okay. And you have to take the intersection of it.
But the intersection belongs to both A complement as well as the B complement, right?
Sorry.
The intersection part, when we actually talk about A complement, we actually take the B and the rest of the A and so on. There the intersection is left. Am I right? The intersection part we are not touching.
1 minute. See, A complement will be apart from this circle. Okay. This is your A. This is B. Apart from this circle, all the other will be A complement. Okay. And apart from this circle, all the other will be your B complement. And you have to take the intersection of it. Okay. So that will be this reason.
No,
This
my
part.
question is like when you are talking about A, yeah, my question is when we are talking about A complement, the intersection
Yes.
part also we are actually, and when we are talking B complement, again the same intersection part is also taken into consideration, am I right? Which is common to both.
Yeah, we have to take the common part. Okay, we are
Okay,
taking
okay.
A complement and we are taking B complement, and the region which is common in both, that is A
That also.
complement intersection B complement.
Yeah. Oh. But this is fine. I mean, this is fine with the regular expression. But I mean, sorry, you're continuing with this thing. Is it over? I mean, is it that's the description for the De Morgan's law?
Sorry.
I mean, is that the? I mean, is it the description for the whole De Morgan's law, or I interrupted? I'm sorry for that.
Yeah, this is the De Morgan's law.
Okay. I mean, my question is the typical IIT question, the tricky one, when they are talking about, when they talk in terms of number for A and B and talking about complement, I'm wondering how this complement number will actually behave. I mean, to decipher that number. I hope you can understand. Let's say A is given a number and B is given a number, and there is an intersection. There is a number. When we are talking about complement, I just want to know how can I decipher that complement number.
You will look at the set. Like I cannot say without the question.
Let's say let's say we say that the A and B is a basket of fruit. That same Venn diagram.
Okay.
It's a basket of fruits, and there are, let's say A is one basket and B is basket, and third basket is an intersection which contains both the fruits.
But here you are taking two different baskets. So how will you take intersection then?
Or in the same basket. Let's say, okay, the same fruit basket, you talk about apple and orange together. Oh, can you actually, am I describing my question properly, or is it still a confusion? I just want to know how that number, if we actually use numbers, I want to know how this complement number will come out.
Like, let's say that this is a sample space. Okay, we have numbers from 1 to 20 in the sample space. Okay, and you have two sets A and B. A contains number from 1 to 15. Okay, and this contain number from 10 to 20, suppose. Okay, so what will be the intersection part? So A intersection B. So it will be like it is from 1 to 15 and it is from 10 to 50, 10 to 20. So it will be 10, 11, 12, 13, 14 and 15, right? A intersection B, right? Is this clear?
Yeah.
Okay. Now you are saying that if you have to take complement of it, right? So that will be all the remaining element which which are not in this. Okay, so it will be like 1, 2, 3, 4 up to 9. Okay, and then from 16 to 20. Okay, similarly, if you want to check for A complement, B complement, A complement intersection B complement, you can do in the same way. Okay, so A complement will be like A is 1 to 15. Okay, so A complement will be 16 to 20, right? 16 to 20. Okay, and B complement will be your 1 to 9. Okay, and if you have to take intersection, then I think intersection will be 5, right?
That will be 10 to, no, fine.
Actually, your voice is very low.
Oh, sorry. I actually updated the Zoom. I think that has put the thing in my audio. I think some issues are there with that. Sorry for that.
Okay. Now is it clear?
Yeah, I can hear you properly.
Okay, yeah, it's clear now, the question, the doubt.
Yeah. Thank you. Thanks a lot.
Okay. So now we can end the class.
Hello, ma'am.
Ma'am, I have doubts in the today's lecture.
Okay.
Ma'am, you shared the
Ma'am, you
PDF, ma'am.
told
Please share the
Uh,
session note.
okay, 1 minute, I'm sharing.
ma'am, can I share my doubts?
So one question to all you guys. Are you facing some problems in solving questions in maths and stats in week 7?
Yeah, I am facing.
So brother, how are you managing?
I used to see the lectures or find notes on the YouTube, right? Like try to solve some PYQs if I found anyone.
But
Otherwise, I will.
plotting graphs are quite difficult, no?
Yeah, graphs are very difficult. I have the same doubts
ये तो
that how
दिक्कत
to
है.
manage the graphs, and especially maths. I found very difficult understanding the question.
Because they are not giving a complete theory for the
Yeah,
questions.
yeah,
Theory complete नहीं है भाई.
yeah.
मुझे भी ऐसा लगता है.
Refer to the previous recordings.
क्योंकि मेरे को कभी भी ऐसा लगता है जैसे जो मैम प्रोफेसर है उन्होंने कुछ और पढ़ाया है, मतलब उन्होंने कम पढ़ाया है और क्वेश्चन थोड़ा हाई लेवल का आ गया है, ऐसा
Guys, sorry
लगता
to
है.
interrupt. Don't disturb. Don't discuss max here because this session is live and recording.
Okay, okay.
Okay. So sorry, ma'am. Sorry. Ma'am, I have a doubt in today's session. Can I share my doubts, please?
Yeah, I have shared the notes.
Ma'am, I wanted to understand what is independent repetition in the relative frequency.
Like outcome of one trial should not be dependent on the outcome of second trial. Okay.
Okay, ma'am. Okay.
I think the notes are not
Ma'am,
uploaded.
Yeah, any other doubt, or we can end the class now?
No, the notes are not uploaded. You said they were shared, but
Yeah, it will be uploaded on the portal also.
Hello, am I audible?
Yes.
Can you please differentiate between classical and empirical probability?
See, in empirical, what we do, we perform an experiment like for a large number of times, and then we see that how many of times that particular event is occurring. Okay.
Okay. Yeah, okay.
In empirical probability, right?
So we are actually performing the experiments.
Yeah, we perform the experiment. Like in
Okay,
the
and in
question, it
class.
will be given. Okay. So it will be given, but okay. Like this is the formula.
So both of them are essentially the same only, na? We are taking a fraction between
Yeah, actually
favorable
they are
outcomes and
similar,
total
but
number of outcomes.
in the empirical one, we perform a experiment a large number of times so that we can get some accurate results, some like reliable results.
But let us say that total number of possible outcomes are already known, and we know that what are the favorable outcomes, then we can simply compute the probability.
Yeah, you can do in that way also.
So
We can
like
use
what is
classical
the
probability.
requirement? Like why do we need a different
Like there
method?
are some cases where we don't know the probability of something. If you want to check, then we can perform the experiment. Like if
Okay.
you have unfair tie, then you can do. If you don't know something.
Ma'am,
And what if we have a case where we don't have the entire sample space available? Like all the possible outcomes are not even known, then what should you do?
Sorry, when you don't know.
Like when we don't know the entire sample space, like all the possible events are not known, then can we like discuss about the probability
In
or
that case, that will not be a random experiment. If you don't know the possible outcomes,
okay,
then it will not be a random experiment.
okay.
Okay,
And
there are
what
many
else can
kind
be
of
there?
experiment. There are also some experiment in which the result is fixed, and they gave you the example of water. Okay, formulation of water. We already
Hmm.
know that if you are mixing these two elements, then it will give you a water. Okay, or you can like if you are solving and if you're doing an experiment, you're solving the equations. Okay, always they will give you the same result. Okay, if you have a quadratic equation, okay, you are finding out the roots. Okay, so whenever you
Okay.
solve the equation, the answer, the roots will be always same. Okay, so this is different kind of experiment, but here we are talking about the random experiment. Okay, so these results are true for the random experiment only.
So based on whether the result is known or unknown, we can have either a random experiment or we can have a like non-random experiment where result is known.
We Yeah, an experiment could be of random also, non-random also.
Okay, and only when it is random, then only we talk about the probabilities.
Yeah, when it is random, then we talk about the probability.
Okay. And one more thing, mutually exclusive means that events are disjoint.
Yeah, events are disjoint. If two events are mutually exclusive, which means if one is occurring, then other will not occur at the same time.
Okay, but what does independent events mean then?
Independent
Like,
means that it will not affect the results of each other. Okay,
so
like you
what
have
is the
two.
mathematical implication? Like for
Uh,
mutually exclusive, we know that the intersection is 5, empty set.
yeah, yeah, independent
But
that you will also study in the week 8. So
okay,
in that case, intersection becomes equal to the product of their individual probability. Okay,
okay,
that you will also study in the further weeks. Okay.
okay,
Yeah. So independent basically that it does not affect the results of each other. Like if so you have two coins, you are tossing one coin, it will not affect the result of other second coin, right? But if you are like throwing a die and you are taking two events, like one is even number occurs and other is odd number occurs. Okay, so you know that if even number 2, 4, 6 are occurring, then odd number cannot occur.
yes,
Okay, so they are kind of mutually exclusive.
yes,
They have nothing in common and they also cannot happen at the same time.
okay,
Okay.
okay.
Ma'am, can you please brief about the mutually
Sorry.
exhausting, mutual exhaust? I-
Exhaustive means like all the events together. If they are mutually exhaustive, then they will make the sample space. Okay, collectively.
Yeah.
That is
Okay.
mutually exhaustive. Okay.
मैम आपके नोट्स अभी नहीं आए?
I have sent it.
Yes, ma'am. In chat, it's not there.
Uh, but in mine, it is showing a green tick.
It is
Oh,
sent
have you sent
sent to
someone
everyone.
directly?
Ma'am, you have sent to everyone.
Let me check it by mistake. I have done to
Hmm.
someone personally. Yeah, now?
Yes, ma'am. Got it.
Okay. Yeah, okay. Now you can leave the session. Okay, we are ending it now.
Give us a couple of minutes. It's downloading.
Okay, okay.
Give us a minute.
Just wait a minute. It is downloading for someone.
Oh, okay, okay.
Thank you. Thank you so much.